Bedwas Geology, Video 3, Unconformities. What I'm going to show you now is how a sequence of rocks can form. Imagine a state 350 million years ago. A nice coral reef, a nice tropical sea. What sort of rock will be forming there? Expect that to be a limestone. Some 100 million years later, on top of the limestone, the climate changes. More likely that the area that formed the limestone has migrated somewhere else onto the Earth's surface due to plate tectonics. It now finds itself in a hot desert climate. So that's going to produce a hot desert sandstone, which represents the next sequence on top of it. Again, plate tectonic movement means that it moves further north, right towards the tropics, and it gets to a hot, swampy area. Now, this type of environment can produce quite a lot of rocks, highly organic rocks, sometimes because of the dead organic matter. In this instance, it produces a very dark black shale, the next sequence, and that was 200 million years ago. Finally, it goes a bit further north, and so we build on top of the sequence there. You can see there's a braided river in a much colder climate, perhaps in the last glacial period, and it produced a conglomerate. So there was the sequence of rocks going up to 170 million years ago. But it doesn't keep building and building. Often you have gaps in time when, after having a series of depositional environments where rock is laid down, you then have a sequence where it's been eroded back down again. So here we see those sequences of four rocks. Let's say 170 million years ago, they were subject to huge compressional pressures from plate tectonic movements. And those rocks were folded up, as you can see in the diagram underneath. Now, those folded rocks, they're not having any deposition from 160 million years to 100 million years ago. So they slowly get worn down by all the processes of weathering and erosion that we know. You can see in the left the action of freeze-thaw. Water enters cracks, freezes, expands, and starts breaking rock off. So our little anticline there is subject to really strong powers of freeze-thaw. It might also be, as you can see in these little extracts, strong waves, rivers constantly breaking it down. And you can see there what we have is our layer rock is worn down to where it is here. Erosion and weathering are thought to have worn away over 7,000 meters of rock above the Appalachian Mountains in the eastern United States. So that represents a gap in time. But let's just go on one bit further. Let's go on to more recently, 100 to 20 million years ago. Here's our worn down anticline, as we saw from the previous diagram. But let's say it does change back to a depositional environment. Here we see an estuarine environment, highly depositional with fine sands and muds. And let's just add those on to that sequence of the eroded anticline. Now you can see now we have this line here, which represents that gap in time, what we call the hiatus. And that represents an unconformity, where there's a gap in time and hiatus in time. The boundary of the unconformity is often uneven, as it was an erosional surface. Here's a famous unconformity in the Grand Canyon. Can you see it? Let's remind ourselves of the sequence. First we had the law of superposition and the law of original horizontality. Then those rocks were folded. Then that anticline was eroded down. Then, after that gap in time, there was further rocks deposited on top. Now, if we look at that picture of the unconformity in the Grand Canyon, you should be able to pick out this boundary, very uneven. Below the boundary was a sequence of Precambrian rocks. Above it more recent tertiary rocks lay down much flat, and that represents an angular unconformity because the rocks are at different angles. Unconformities are also common questions on maps. This is from 2014. You should be able to pick up quite clearly that this is the unconformity. What do we look for? Well, firstly, there are different dips to the surrounding beds. Here we see these beds are dipping at 30 degrees. However, this cross here, this one here as well, tells us that this bed is laid down flat. Also, there's cross-cutting. You can see quite clearly that these beds here are not the same or cut right across the other beds.